right, so let's talk about the last section here, which is analyzing a ransomware attack. And this is pretty great stuff. So here we are in Splunk. All right, now I'm going to go to Splunk 1 because I think it's got less traffic. Splunk.samsclass.info. You just trim everything else out. There we go. All right. All right, so the first question is, there's a, go to search and reporting. That's weird. Search and reporting, I said. Refresh, maybe? Search and reporting. Okay. Looks like we're okay now. All right. So the first thing is they want to know this machine named We8105 Desk. So that's the host name of one of the machines. So I'm going to turn on some event sampling and search all time because there's going to be a lot of these. I'm going to find 181,000 events. All right. And so here's the source field. There are 10 different source values. Okay, 18,000. I'm only getting 9 with my sampling, but let's see. Here's various types of source, and you want to find a stream event which is used in Active Directory logins. And the one that is easiest to identify, we're trying to find the IP address of a machine on a certain date. So LDAP is Lightweight Directory Access Protocol. That's probably the most helpful protocol to see who's logging in. And so now I want to limit it to that day. So I'm going to get rid of the sampling, and I want to get events on 24 August 2016. So I should be able to specify the date up here. Date range between 24 August 0824 2016. And I guess 0825. Not sure if the date range is the best way to do it, but anyway, this gets me close. Oh, this is from 0 to 2400. If that's true, then putting a 24 here should get me all day that day. If I'm understanding this correctly, let's see if that works. Find events on that day. There are 48 events on that day, and look at their IP addresses, and you can see the destination IP is always the same, and the source IP is always the same. So there were 50 LDAP events on that day, and the source IP is 192.168.250.100, which I think is the IP address of the endpoint, just the way IP addresses are usually assigned. I'm going to put you a note here. This is We8105 IP, and the destination IP here is, this is more likely the server, the smaller number. The one ending in 20 is typically the server, and the one ending in 100 is typically the client. So that is probably the IP address of this thing on that date. Now, the Suricata detected the server malware. So, I'm just up to the flag 4.2. So let's start with server, the name of malware, and just search for that, and go back to all time. All right. We're going to find 21,000 okay, events. Now if I look at the source field, there are 4 values, and I want to find the Suricata events. So that would be these events. And I'm looking the Suricata signatures that detected it, which one triggered the fewest number of times. And so down here I will find alert signature, and there you go. So it observed server check-in Go menu domain lookup and check in, so you can find the event that triggered the smallest number of times, and there's a Suricata event ID someplace or other. The flag is the signature ID, which is down here, signature ID. There you go. That's where you get the actual ID number for the flag. Okay. Now, the server ransomware, the way it works, the ransomware works, first somebody runs a script, it then encrypts a bunch of files, then it opens a ransomware page, which is a hidden domain, typically an onion domain lookup. And so we want to find the Suricata alerts about onion domain lookup, which we just saw. If I go up here to alert signature, okay, here's the onion domain lookup. And we're trying to find the FQDN, so restrict the time to within 1 second of these dimensions and look at stream DNS. So here we are, onion domain lookup. If I look at those events, there are 2 events, and they're both at exactly the same time, 10:15:12.668 on 8:24. So I want to restrict time to within 1 second of this time. So I can just click it here and restrict it here to 1 second of that time. This is a great way to do it because you don't have to get involved in time zones, which can be very much in the way otherwise. And now I can remove, I want to find stream DNS events here. So get rid of all the other criteria and do stream DNS. And didn't work. Okay, I'm just going to go back to star and look at the sources. Source type, stream DNS. There they are. When I typed it in, I didn't put the quotes in correctly. So now there's only 16 events. And if I look at the queries, I can see the DNS queries made within 1 second of that alert. And there you are. These are innocent Microsoft ones, and there it is. That's the malicious domain. I don't really understand this. I thought onion domain names always had to end in .onion, but apparently this is also recognized as a server malware onion domain lookup. So that's the fully qualified domain name. Now, the next thing is to find the suspicious domain visited by we8105 desk. So we're on 24 August 2016. So I'm going to get a clean query, and I want to find Suricata events. So I'll go here and source types and find the Suricata events, which are here. And for now, I'm going to turn on some event sampling to make it faster. And now I'm going to go to that day. So this again is a date range. I want 24 August 2016. So it's 08/24/2016. And that should do it. That should give me all that day. All right. So now I'm going to get Suricata events on that day. And I want to look at the source IP field. And I want to only have the IP address of the we8105 desktop, which we found before, and is this one, ending in 100. Now we look at the event type. Event underscore type, okay? And we want to find the events that load web pages. Those would be the HTTP events. And there are 3 of them, but that's because I have sampling turned on. I turn off the sampling, there are really 38 of them. Now we can look at the host names visited. We're trying to find what suspicious domain this person went to. And here's HTTP host name. And again, a bunch of them are obviously innocent, like Bing and Acronis. This is the funny looking one, solidarityproximity.org. That's a malicious domain. It's just a funny looking domain. And you can find out it's malicious by just Googling it again. If you, I guess, use a private window in Google to make Google work. So let's try that, since that worked so badly last time. Let me open a private window here. Go to google.com and see if it's going to work right now. We search for solidarityproximity.org. There's a ransomware attack showing server uses this domain. That's what I thought. Pretty easy to find evidence that it's clearly malicious and related to this ransomware attack. All right. Now you can actually find the Visual Basic script that was used to make the to perform the encryption. So if you look for VBS and EXE, Visual Basic Script and .exe, all time again. There are 16 events that mention both of these things, and if we just look in the body field, we can find the malicious one. So here, a new process has been created. New process has been created. These look like generic messages. This one is all full of funny looking script. And in fact, here's a random VBS, and you can see that funny capitalization and this crazy name GNPI. This is obfuscated script. This is obviously malicious. And so then what's the name of the first function defined? You saw it there. All right, so that's the VB script. Now we want to find the field length, which is a little annoying. You have to refer to something and find the length of a Splunk field. I'm not going to dig into that too much. And then we want to find a USB key, which is pretty fun. Let me see, I've got a link here. Hopefully it will work. Yeah, USB registry entries. When you plug in a USB device, it makes registry entries, and you can see it in the registry traffic. So let's see if we can get this one to work. enum USB subkey. Let's look at registry entries. And go back here. Let's start a new search. And data summary. And source types. Windows registry is here. So we should be able to find registry stuff here. And I'm restricting the time to something funny. Let's restrict the time to all time again. Okay. So there are some registry events. And now let's try USB. And that gets us down to 313 events. And here's the registry key name. And the registry path is here. System enum USB. This is what we're looking for. enum \USB. So I might be able to do this. enum \USB. Let's see if that narrows it down a bit. Nope, it won't accept that. All right. All right, we want to find the name of the USB key inserted by Bob Smith, and want the enum USB subkey, which is the key name, which is not being very easy. But I think what's better is to, I think we need to find the friendly name. Now let's look at this link here. To find the readable name of the key, I'm pretty sure it's called friendly name. There. If you look at, yep, there it is, friendly name. A name like super much. So I think we can add that. Might be able to just put it up here. Nope. All right, we've got to find it, but it's not that easy to find. So I don't know if I'm going to have any success here. It's the enum USB subkey and find the most readable name. Let's see what objects we have. Registry key name, registry value type, registry type. Well, I may not be able to figure this out. I haven't left myself enough hints to remember how to do this one. Object path. So I'm going to go on to something else. Some of you brilliant students might figure this out, and I'll have to write more extensive hints here guiding me to it. All right, but I think I'm going to stop. I'm falling off the track here. We'll handle these with student questions. Let you get you started on the ransomware attack. There's one I like where you actually get to see the script that does the ransomware. And I guess we've already seen that. That was the obfuscated script we saw earlier. All right. I think I'll stop this video because I'm not helping very much. All right.